Okay, so picking up where we left off down here at the bottom, we are going to pretty much follow the same procedure, except up at the top when we work through these. It just so happened that the y was by itself in both equations that were given, and that's not going to be the case here. And so if we take a look, there is no y equals. The first equation doesn't have either one of the variables isolated, although you could move this one pretty easily if you wanted to, minus 7y on both sides, and you'd have it. But there's no need to do that because the second one is already set up nicely. X equals this whole thing. So when you have one of your two equations in a system already set up where one of your variables is isolated, you are all set up for substitution. If x equals this, that means I can come to the other equation and change x or substitute in for x, that value. Now again, x doesn't equal 5, where I can just plug in 5 for x, but it equals y minus 7. And so I'm just going to plug in y minus 7 for x because that's what it equals. This says that they're the same thing. They're equal to each other, which means I can come up here and I can put that in. Okay, so I'm going to actually rewrite this whole thing, but instead of the x, I'm going to put in what x is equal to. X is equal to y minus 7. So rewriting this, but with y minus 7 in for x, plus 7y equals 49. All right, now all I got to do is solve this. Now, when we were on the other questions up here, we had variables on both sides, so don't fall into the trap of doing the same thing. These variables are on the same side of the equal sign, right? Here's my equal sign. So that means I'm just going to simplify them and put them together. So it's a y and a 7y. That's an 8y. Don't try and subtract them from the same side of the equation. You can't do that. You can only subtract once on this side and once on that side, and it wouldn't make sense. Okay, so these are on the same side. Put them together, and I still have a minus 7. To solve this, I'm going to get y by itself now, so adding 7. Divide. And so y equals 7. Now, just like we talked about before, you're not done because all we know is what y is. We need to know what x is. We need the ordered pair. We need to know what is the one point where we have an x and a y value that if we plugged them in, it works for both of these equations. So we've got the y value. We're going to go back to one of these, and we're going to plug it in. Now, it really starts to matter. Now, technically, it doesn't matter. So let me watch my words there. It doesn't matter which one you put it in, but you really can save yourself a lot of time is what I'm trying to say. And you should really be observant of where do I want to plug this y into. So I could plug it in up here, change this to a 7, solve it. It really wouldn't be that hard. Okay, you could do it, no problem. But if you just plug it in here in this equation, all you have to do is make this a 7, and 7 minus 7 has your answer. Okay, so out of the two, you want to choose the easier one because why not? Make your life easier. So again, either one of these equations can be chosen. It does not matter. They're both going to give you the same answer. So I'm going to just take this one and make sure you plug in for the correct variable. We found out that y equals 7. So we're going to change that y to a 7. And 7 minus 7 is 0. And we've got our answer. X equals 0. So there's our solution. There's only one solution. Make sure they get in the right order. It's an easy mistake. X comes first, x comma y. So 0, 7 would be the point on the graph that these two lines would cross. And it's the only ordered pair that makes both of these equations true. If we went in and plugged in 0 for x and 7 for y in both of them, they both would come out true. And that's the only pair that makes that happen. All right, so again, like we did in the first part, I suggest you pause the video and try this one, and then see how you did. So I see that I already have x equals, which means I'm all set up for substitution. So if x equals that means anywhere I see an x, I could substitute. Now you're always going to the other one. And so here's my x in the other equation. I can change it to this whole thing because x equals this. Therefore, just like if x equaled 10, I could put 10 in. X equals 3y plus 5. I can plug 3y plus 5 in. So what's that going to look like? So the 2 is still there. It's times x, right? 2 times x. So it's 2 times this whole thing. So I'm going to put it in parentheses. That's the way you should do it. It's 2 times x. This is x. X equals 3y plus 5. It's 2 times this whole thing. and then just write the rest. Minus 4y equals 12. Okay, a little bit longer to solve here. Of course, we're going to distribute and simplify here. So multiply, you get 6y. Don't forget to multiply, that's 10. Okay, don't try and subtract from both sides of the equation because your variables are already on the same side of the equation. So you just put them together. So 6 and a negative 4, or 6 minus 4, is 2y. You still have plus 10, minus 10, and divide. And so y equals 1. Now we have y, we can go back and we can solve for either one. I highly suggest that you choose this one. It just looks a lot easier. So y is 1, I'm going to plug it in. So first, let's bring this equation over here. And now we're going to substitute 1 in for y. So 3 times 1 plus 5. So x equals 3 plus 5. So x equals 8. So again, there's one solution. And you give it as an ordered pair, x first. So 8, comma, 1. Okay. So there's two different kind of problems we see here on the front, but they're very similar. You got to look for the equation that's already either in x equals or y equals form, and then use that to substitute into the other equation. Now, all 4 of these, we ended up with one single solution, where if these were lines on a graph, they would cross in one spot. But we also looked at what happens when there's ones that don't cross on a graph, where there's no solution, or if they actually run on the same line, and there's an infinite number of solutions. So we need to look at what do those look like when we're solving algebraically. So that's what we're going to look at on the back here real quick. So if you take a look, here's my y by itself. It equals this, which means I can come up and plug in for this. Y equals this, so I can change y to this. So I'm going to rewrite this whole top part, 4x plus 2, and then instead of the y, I'm going to substitute negative 2x plus 3 equals 6. So it's important to see what I'm doing. I'm just taking this equation and rewriting it, but instead of the y, it says 2 times y. Now it's 2 times negative 2x plus 3. Okay, you got to simplify. So I'm going to leave the 4x alone. Multiply, that's negative 4x. Multiply, that's 6. Can you see what's going to happen here? So the 4x plus the negative 4, those cancel. They go away. That's 0. And you're left with 6 equals 6. Hey, that's a true statement. And this is one of those infinite solutions. And if it was on a graph, if you graphed both of these lines, they would both end up right on top of each other. You'd have this line, and then you'd have the other line. And anywhere you go on either one of those lines, they're going to have a pair, an ordered pair, that works in both equations. And so you would say they all can solve for this system of equations. So that's what infinite solutions looks like. The x's go away, and you have a true statement. So let's see what happens for no solutions. That's what this one's going to be. So first of all, I've got the x already isolated, which means it's equal to this. So I can come to the other equation, and I can change the x to that. So I'm going to rewrite this equation right here, but instead of the x, I'm going to substitute negative 4y plus 8. So it's 2 times x. So instead of x, it's 2 times negative 4y plus 8. The rest of it just gets written down. There's no x's to substitute for. Okay, it's just simplifying. Multiply, that's negative 8y. You multiply here, that's positive 16. Nothing happens to the rest yet. When I go to simplify this now, I've got a negative 8y, and I'm going to add the other 8y. They're on the same side of the equation, right? So I'm not subtracting from both sides of the equation. I'm just combining, and those cancel. Positive 8, negative 8, that's 0. So what am I left with? I'm left with 16 equals negative 40. Well, that's not a true statement. 16 does not equal negative 40. So this is one of those cases where there is no solution. And we talked about a couple different ways you can write it. You can even just write the words no solution. And what would this look like on a graph? These would be 2 lines that never cross, And don't forget what we call those. Those are parallel lines. And that means if you arrange these in the form that you could find the slope, they would have the same slope because parallel lines have the same slope. They're going to go up and over the same amount. Okay, so there is no solution for this one.